Hi everyone, my name is Madelon Hulsebos and I'm a PhD candidate at the University of Amsterdam. Unfortunately, I cannot make it today live as I'm at a wedding in Italy, but I really want to thank the organizers of Data for having me to present to you GitTables, which is a large corpus of relational tables. So let's first start with why we actually need a corpus of relational tables. Well, I think by now we have seen the immense capabilities of representation and generative learning for example, images, natural language, and also code. But what about tables? So in my opinion, tables are really a promising modality for representation learning with way too much application potential to explore. That is, the tables are really predominant data modality in the data landscape, as illustrated by, for example, the popularity of the relational database management systems by DB engines, but also the dominance of tabular file formats as indexed by Google Dataset Search. And it serves many, tables serve many applications across the end-to-end data analytics pipelines, from data integration all the way to data visualization and machine learning. So what are the appropriate existing data sources? Well, currently we have tables from the web. So for example, web tables or wiki tables, and they serve powerful web applications. But web tables do not really resemble database tables well. So when it comes to data tasks on offline tables, what tables could we actually use? And there we explored GitHub as a potential data source. So here I explored all CSV files with the term ID in it, and I found here that GitHub already stores close to 16 million CSV files with that term. And here you see the relevant kind of data that these CSV files exhibit. So here you see identifiers and much of like numeric measures, which are not so typical in web tables, for example. So we concluded after some experiments that GitHub is a viable data source for a large-scale data corpus. So this landed to the creation of GitTables. So on a very high level, we extract all CSV files based on terms and topics from WordNet, which we then parse to actual tables. And we also do some additional curation, but for more details, I would like to refer to the paper as presented at SIGMOD this year. And from those parsed tables, we annotate them with column semantics using a syntactic annotation procedure and a semantic annotation procedure, so that we have a corpus of tables with rich column level metadata. So onto some properties. So we now publish 1 million tables and also the underlying 800,000 CSV files through Zenodo. And these tables come within, on average, 142 rows and 12 columns. And that's already much more than the 11x4 tables from web tables. And well, they come with lots of annotations from columns, and we have many types with at least 1,000 columns. So that will be helpful for example, column type detection models. And I want to note here that the identifier semantic type, so ID, is a top 1 type in GitTables, while it is not in the top 20 in web tables, which really illustrates the different kind of semantics in these corpora. And we show the application potential of GitTables through 2 applications, type detection and header completion. So for type detection, the goal is to annotate columns with the semantic types, for example, ID or age, and so on. And we evaluate it on GitTables and show good performance, 0.86 in F1 score. But we also train a model on VisNet, which is a collection of all existing web table corpora, and evaluate that model on GitTables. And there we see that the performance of that model drops from 0.77 in distribution to 0.66 when evaluated on GitTables, which illustrates the clear gap between these corpora. We also illustrate the use of GitTables for header completion in databases. So given a set of initial attributes, what are relevant attributes to complement this with? And we show that, for example, for the header prefix, payment idea, and customer idea, you get really relevant suggestions of review idea, product idea, etc. For the more quantitative evaluation, I'd like to point also to the paper. And this can be useful for example, data augmentation or knowledge base enhancement applications. So to summarize, GitTables is a large repository of relational tables, which better resemble typical database tables and come with rich table metadata. We find that it's very effective for tasks such as header completion and type detection, but others have also been using GitTables for join discovery, schema matching, and also tabular file parsing. For more information, please go to gittables.github.io or reach out to m.hulsebos@uva.nl. I also really encourage to reach out for feedback, suggestions, or questions. And with that, I really like to thank you for your attention.